so let's talk about double integral. Woo. So last time I kind of teased this, right? Okay, so last time we said something like, okay, if we want to integrate over a rectangle, right? Some function. So we take our function, f of x and y, and we say integrate like dx, dy or something?
Yeah.
Yeah?
And then you have a double integral midpoint.
Okay, there's two integrals. One's for x's, right? That goes from a to b, and then there's one for y's, right?
Yeah.
C to D.
Maybe c to d. Okay, so the thing that's happening, right, is there's some kind of a surface. There's a y-axis, an x-axis, right? And then there's some rectangle in here that I'm integrating over, right? So maybe blue for the thing I'm integrating over. So we got to come up to the surface, and up to the surface, and up to the surface, and up to the surface. And so I get some kind of little thing, right? And I'm calculating the volume under that. You guys all cool with this? Okay, so your book writes this in a slightly different way. They write the single integral over a region R.
Which you have to define.
Yeah, so that's here. That's this guy. Right, that's a rectangle. I sort of said that was A to B by C to D, right? They just say, what the heck? Let's not write down the x and y's, right? We'll just say over the region R, we're going to integrate f d. Yeah, they use A for area, right? You guys see that? Okay, how else should I be able to express this thing? Let's try this. Yeah, okay, so this is the volume under the surface, right? But what if I did A to B, C to D?
dy dx.
Just be dy dx.
So I do f of x and y, dy dx, right? So you should probably wonder to yourself, when are these actually the same, right? When can I switch the order? Pretty much always you can switch the order.
Oh.
Okay, so that's what I'm going to write here. I'm writing pretty much always. We're not going to talk about what not always would look like. There are a couple examples for this. They are pretty frickin' pathological. Okay, so reasonable engineering things, swap the order, go for it. Continuous things, swap the order, go for it. Moderately discontinuous things, swap the order, go for it. Really, really horrible things, consult an adult. Okay?
An adult? Are you sure you're not supposed to consult a computer?
Yeah. Because anything unreasonable a computer can't do.
Oh, okay.
Right? Because, of course, a computer tries to approximate, and the upper sums and lower sums will be really wonky. Right? You basically can't get a computer to you're not going to be able to tell a computer about the functions that are going to be problematic without it truncating, approximating, or something else. Okay? I want to give you guys a little flavor for what we're doing here. So here where I'm integrating dx first, right? New color. Maybe still the blue, I guess. When I'm integrating dx first, right? How am I going to actually do that?
Integrate with y as a constant.
Yeah, I'm going to set y as constant, right? So if I peg y as a constant, I'm going to get a one-dimensional integral, and that's going to give me the area of a slice like this. You guys see that? So this area of a slice, right? That's going to be the integral of f and x dx, right? With y held constant. think this instead of actually is this, right? So I'm slicing along the y's, and then what am I going to do when I integrate dy? So once I've already sliced, right, the other integral, the dy integral, is going to add up the volumes of those, or the areas of those slices. You guys see that? When I do it the other way, right, so when I do the integral dy first, if I've got my surface, doing dy is going to hold x constant, right? So I'm going to get some slice like this. And then I'm going to add those up in the x direction. You guys see that? And when we do this thing, what are we thinking? This integral over a region dr.
It's the little
Little piece.
rectangular tower things.
Yeah, this is literally those little rectangular towers. You guys see that? Or some other stuff that we don't have right now. Cool. For right now, I want you to know that to execute this thing, you're going to have to pick an order. Right? That's going to be one of these two, or use some geometry. You guys cool? This is kind of the general object. To actually get a number out of it, I'm going to have to kind of pick an order and define things a little better. Cool? This thing is nice because I dropped the x and the y. Did you guys see that? So here, if I changed coordinate systems, remember those two coordinate systems we did at the beginning? Yeah, so we did polar first, right? So that was our other area coordinate system. So here we could maybe figure out what dA is in terms of polar. And then we could think about f as r and theta. And we could do whatever dA is, and we'd just do that, right? You guys see that? That gives us another option. When we do volume, we'll have 3 of them. For area, we just have 2.